Indices. Indices are a shorthand way of writing a repeated multiplication of the same number. So instead of writing 2 times 2 times 2, we can write it as 2 to the power of 3 or 2 cubed. So 4 times 4 can be written as 4 to the power of 2 or 4 squared. 2 times 2 times 2 is 2 cubed or 2 to the power of 3. And 8 times 8 times 8 times 8 can be written as 8 with a 4 as a subscript and pronounced 8 to the power of 4. And it's just important that whenever you're writing it in this format, that you make sure that it's obvious that it's a superscript. So 8 to the power of 4. So the 4 is up high and it's quite small, rather than 8, 4, because that could obviously be confused for 84. For numbers to the power of 2, we always say squared. For numbers to the power of 3, we always say cubed. And for all other numbers, we say to the power of. So in 3 to the power of 4, the base is the big number and the index to the power is the small number. And what it means is 3 times itself 4 times. So it doesn't mean 3 multiplied by 4, which would be 12. So that's not what it means. It means 3 multiplied by 3, multiplied by 3, multiplied by 3, which clearly isn't 3 times 4, but that is 81. So just be careful whenever you're doing that. So the base number then is always the number we're multiplying by itself. The index or the power tells us how many times we multiply it by itself. So it's got nothing to do with multiplying the two numbers. So as I say, 3 times 4 is definitely not 12. So some examples on this. The first one is 3 times 3 times 3 times 3 times 3. And we can see that there are 5 3's being multiplied together. So that's going to be 3 to the power of 5. Second example, 5 times 5. So there's 2 of them. So that's going to be 5 squared. And then the last one, let's exaggerate it somewhat, times 19 times 19 times 19. That would be, there's now 1, 2, 3, 4, 5, 6, 7, 8 of them. So that would be 19 to the power of 8. Example 2, expand. So expand just means we're going to write it out in full. So if we have 2 to the power of 5, that's going to be 2 times 2 times 2 times 2 times 2. And there's 1, 2, 3, 4, 5 of them. So that's good. Part B then is 4 to the power of 2. So that's going to be 4 multiplied by 4. And then 5 to the power of 3 is going to be 5 multiplied by 5 multiplied by 5. Example 3 then is expand and then evaluate. So that evaluate means we're going to actually work out the answer. So part A, 4 squared. So 4 squared we know is 4 times 4. And 4 multiplied by 4 is 16. Again, the common mistakes some people will do there is they'll say 4 squared is 4 times 2, which is 8. But that's not right. Squared means there's 2 4's being multiplied together. 5 cubed means there's 3 5's being multiplied together. So 5 times 5 times 5. 5 times 5 is 25. 25 multiplied by 5. So 5 times 5 is 25. 5 and carry a 2. 5 2's are 10 and 2's 12. So the answer is 125. 10 to the power of 2 means that there are 2 10's being multiplied together. So that's 10 multiplied by 10, which is 100. 50 to the power of 1 means there's 150 being multiplied together, so it's just 50, which is just 50. So anything to the power of 1, so 50 to the power of 1 is just 50. 17 to the power of 1 would be 17. And similarly, we could also say then that 8 would equal 8 to the power of 1. So any number could have 1 as its power. Writing simple numbers as a power of a prime number. So what we're going to have is we want a prime number. So the prime numbers we should be familiar with by now. So we've 2, 3, 5, 7, 11, 13, 17, and so on. So prime number is a number with only 2 factors. So we want to express simple numbers as a power of a prime number. So 27, what we would think about it, it's 9 multiplied by 3, but 9 isn't a prime number, so we need to express 9 as 3 multiplied by 3, multiplied by 3. So the 9 there was this 3 times 3. And then what we have is 3 times 3 times 3, which is going to be 3 cubed. To get 8, 8 is 4 times 2, but again 4 is not a prime number, so we need to try and express it, and that's 2 times 2, which we're multiplying by 2. So again we've got 4 and it's 2 times 2, and then what we've got now is 2 times 2 times 2, which is 2 to the power of 3. And then 25 is 5 times 5. And 5 times 5 simplifies to 5 squared. Simplifying a mixture of numbers to index form. So whenever we've got different numbers, we can only group them up in terms of the same base, the base being the big number. So it's really good practice in these for us to write them out in numerical order. With multiplication, the order doesn't matter. So if we have 3 times 2 times 1, that's the same as 1 times 2 times 3, which is the same as 3 times 1 times 2, which is the same as 2 times 1 times 3, and so on. And all those answers work out to be 6. So the order doesn't matter. So if we've got 2 times 3 times 2 times 2 times 3, if we write it out in numerical order, that's 2 times 2 times 2 times 3 times 3. The 2 times 2 times 2 can be expressed as 2 cubed, and the 3 times 3 can be expressed as 3 squared. Example B, we've got 3 times 5 times 5 times 3 times 7 times 3 times 7 times 5. Again, if we put them into numerical order, we've got 3 times 3 times 3 times 5 times 5 times 5 times 7 times 7. So the 3 times 3 times 3 we can simplify to 3 cubed. The 5 times 5 times 5 we could express as 5 cubed, and the 7 times 7 as 7 squared. So we have 3 cubed times 5 cubed times 7 squared. And with both of these examples we can't combine them in any way. So it would not be true to write 5 to the power of 5 or 6 to the power of 5 or any other combinations of 5s or 6 or anything like that. We can't do that. Expanding and evaluating a mixture of numbers. So example 6, expand and evaluate. So we've looked at expand already, and that means to write them out in full. So if we expand 2 cubed times 3 squared, that's 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. So we've 3 2's being multiplied together and 2 3's being multiplied together. Then we work them out, so we can multiply from left to right or right to left, so smallest to biggest or biggest to smallest. And I always find multiplying the biggest numbers first of all is easier, because multiplying by a small number at the end is easier than multiplying a larger number by a big number. So I would do 3 times 3 is 9, and then 9 times 2 is 18. 18 times 2 is 36, and 36 times 2 is 72. Now you could have done it the other way, where 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. So the order doesn't matter, but in my mind anyway, 24 times 3 is a harder thing to do than 36 times 2. Example B, again, write it out in full. That's what the expand means. So that's going to be 2 times 2 times 2 times 5 times 5. So we've got 3 2's being multiplied together and 2 5's. Again, the way that I like to think about it is go big to small. So 5 times 5 is 25, times 2 is 50, times another 2 is 100, times by 2 is 200. And that would have been the same had we gone the other way. So 2 times 2 is 4, times 2 is 8, 8 times 5 is 40, and then 40 times 5 is 200. And again, I just think in my mind, multiplying by 2 is easier than multiplying by 5. And whilst these numbers are easy to do, if you were multiplying by 7 or by 11 or by 13 at the end, that's going to be a lot more difficult than multiplying by 2. Tricks for checking whether a number divides by 2, 3 or 5. So what we know are all the even numbers, or all the multiples of 2. Whenever we think about all the multiples of 2, they are 2, 4, 6, 8, 10, 12, 14, and so on. And all the even numbers end in 2, 4, 6, 8, or 0. So they are going to be divisible by 2. So any number that the last digit is an even number is going to be divisible by 2. A number is divisible by 3 if the sum of the digits is divisible by 3. So if we have 1234, those digits are going to be 1 plus 2 plus 3 plus 4, which is 10. 10 is not divisible by 3, so 1234 won't be. But the number 987 is, because 9 plus 8 plus 7 is 24, and 24 is divisible by 3, so 987 is going to be. And again, to check if the number is divisible by 5, so all the multiples of 5 are 5, 10, 15, 20, 25, and so on. So we say all the multiples of 5 are numbers ending in 5 or 0. So if a number ends in 5 or 0, then it's going to be divisible by 5. The thing as well with these rules is that we can combine them to check if they work for other divisors. So to see whether a number is divisible by 6, for instance, we need to show that it's divisible by 2 and that it's also divisible by 3. So 987 is divisible by 3, but it's not divisible by 2 because it ends in a 7. So therefore 987 won't be divisible by 3 or by 6. But 984, that would be divisible by 6 because it's an even number. So it has that fact that it's divisible by 2. And whenever you add the digits together, you get 21. So that means it's going to be divisible by 2. So because it's divisible by 2 and 3, that means it's divisible by 6. And again, if a number is divides by 3 and 5, then it's also going to be divisible by 15. Example 7 is 8,820 divisible by 15. So for it to be divisible by 15, 15 is 3 multiplied by 5. So 8,820 would need to be divisible by 3 and also divisible by 5. So the number ends in a 0. So that means it is divisible by 5. So now we need to check that it's divisible by 3. So 8 plus 8 plus 2 is 18. And 18 is a multiple of 3. So that means it's divisible by 3. So because 8,820 is divisible by both 3 and 5, then it means it's divisible by 15.